Good morning, afternoon, or evening. Welcome to the 10th paradigm, which is representationalism, paradoxically represented by the book Vision, written by David Marr. Let's go. The book is divided in three parts. The first part comprises one chapter and is the philosophy approach. It's mainly the part that we will speak about in this presentation, but there are two other relevant parts for those interested in reading further, which are from chapter 2 to 6 for the analysis, and chapter 7, which is basically a compilation of questions and answers after the conferences and conversations that Marr had about this approach. One relevant thing about this presentation is that we will try to go through this content via his most pedagogical examples and relevant metaphors. So, for example, we will speak about the flock of birds, gas in a bottle, the Arabic and Roman numerals, bird flights, or the shape of a cloud. Marr had unfortunately a really brief life. He died of leukemia when he was very young, but in his short existence, he made really important contributions integrating psychology, artificial intelligence, and neurophysiology. The object of research of this book is vision, understood as the process of discovering from images what is present in the world and exactly where it is. It's not about processing the information, but also about representing the information internally in our heads. So we take what we see in the world and we create these representations that we will define in a moment in the further slide. But before, let's start with the question that Marr poses just at the beginning of the book. What does it mean to see? And please feel free to pause the presentation and think about it carefully. Does it entail, for example, to have an eye? Does it entail to have a human brain? Could, for example, a robot or a street light see? The first pages of the chapter 1 are basically a state of art of the research on vision. And Marr mentions Newton and his work on optics, Helmholtz, and his treatise on physiological optics, and Wertheimer, and some experimental studies that pointed out the holistic nature of vision, and, for example, how we categorize objects as fields rather than just dots. From this, he also points how seeing a flock of geese as a single unit, instead of as a collection of many individuals, led to the development of the Gestalt School of Psychology, which attempted to basically define laws behind this tendency towards grouping and attributing qualities. Marr tries to understand vision from a different approach, and this is what he suggests in this book and what he tries to contribute to this field. This approach and paradigm is representationalism, which is the philosophical theory of knowledge based in the assertion that the mind perceives from the mental images, representations, of material objects outside the mind, not the real objects themselves. This calls into question if these images accurately correspond to the external world, to the external objects. And some reference on the domain of philosophy could be Descartes, Locke, Hume, or Kant, for example. Let's start with some definitions. As conceived by Marr, a representation is a formal system for making explicit certain entities or types of information, while a description is the result of using a representation to describe this given entity. We will see this with example of numerals. For example, to describe the number 37, we have the decimal description, which is a 3 followed by a 7, which makes explicit the decomposition of this quantity in powers of 10. If we would write this in a binary description, it would make explicit its decomposition in the powers of 2. And if we would write it with the Roman description, it would make evident its decomposition in 1, 5, 10, 50, 100, and 500, which were the symbols that we had in the Roman numeral system. Can you think of other formal schemes of representation? Understanding formal scheme as a set of symbols which has rules for putting them all together. feel free to pause and think about it carefully, because you're surrounded by thousands of different formal schemes of representation. Some of the more ubiquitous ones are, for example, musical scores for melodies, or the alphabet for writing words, which we are using right now in these slides. And how we represent a content is something that has profound implications on how useful, how accessible, and how efficient operations can be performed with it. It makes explicit some properties, or it pushes into the background some other features. And that, for example, can have consequences as important as the development of mathematics, which was powered by the Arabic numerals, and how they facilitate to deal with quantities, which was impracticable with Roman numerals. Following to the next section, Marr poses how we try to understand, for example, the gas in a bottle and thermodynamics in different levels, both a microscopic level and a macroscopic level. So we gather these different properties, such as temperature, pressure, density, or the relationship among these factors, and we try to understand this system consistently in these different levels. He pretends and he attempts to do something similar for vision. This is the full quote about his book. I think it's utterly beautiful. I recommend you to read it entirely. But basically, it says that trying to understand perception by studying only neurons is like trying to understand a bird flight by studying only the feathers of a bird. And to understand aerodynamics, we need to understand the structure of the feathers, but we need to understand many, many other factors. The purpose of these three levels of representation is to illustrate different levels at which an information processing device must be understood. We would have, first of all, the computational theory, which is characterized by mapping from one kind of information to another. Then we would have representation and algorithm for the input and the output, and the algorithm for transforming one into another. And the hardware implementation would be about how to physically realize all of this. Some properties of these three levels is that they are logically and causally related. They are also coupled, but they are only loosely related. So let's see how this takes the shape in questions. For example, computational theory would be about the goal of computation and how to carry that out. Representation and algorithm would be about how to represent input and output and what is the algorithm for this transformation. While hardware implementation would be about how physically can we realize all this. Here you have some material to extend on these three levels of representation by Marr. In this next section, Marr basically tries to propose a representational framework that could help us understand shapes in the world. He starts with a really beautiful quote by Austin, who points how even the most paradigmatical circular shape, which could be a coin, can be seen as something elliptical from a lot of points of view. And he asks, what is the real shape of a cloud? Or what is the real shape of a cat? Does this real shape change whenever it moves, or if it has another posture? Does it change related to the proximity and the distance of the object? Can we really see the hair of this animal? Going back to the representational framework about shape, Marr proposes that we first see a dimensional image and we process it in different stages, starting from a primal sketch, from which we extract the significant information, highlighting its geometrical distribution and organization. And then we go to the consecutive 2.5 dimensional sketch, focusing on the image orientation and the visible surfaces and a more viewer-centered coordinated frame. After which we can go to the three-dimensional model representation, which we really start to see an object-centered coordinated frame. As a conclusion, we understand vision as a process that produces from images of the external world a description that is useful to the viewer and not cluttered with relevant information at all. It is thought as a mapping from one representation to another, and in the case of human vision, consists of an array of images with different intensity values as detected by the photoreceptors in our retinas. In the subsequent parts, in the second chapter, she has takes into account for main factors responsible for the intensity values in an image as geometry, reflectance, illumination of the viewpoint, which was really visionary and sketched the basis of many three-dimensional softwares that we can see nowadays. And that's all. Thank you very much. Hope to see you engaged with a lot of discussions and questions very soon. Thank you for your time. Have a nice week.